What's up everybody? My name is Moss Norman and today's video is a DevOps tutorial. We're going to be doing data analysis using Python and the Jenkins API. I'm going to show you how to use at a high level how to use the Python module that we use to interact with the Jenkins API. And then I'm also going to show you how to plot Jenkins build data using another Python module that you might have used in the past, matplotlib. Basically, today's video is going to be a code walkthrough where we write the code and then take a look at the data that we produce and interpret that data. We'll also talk about some of the other metrics that you can pull using this Python module as well. So who is this video for? You're likely a DevOps engineer or a full stack developer if you're watching this tutorial. I would expect that you have some familiarity with programming, also familiarity with Jenkins, and general Python programming knowledge. In this video, I won't be going over Python setup and setup of your IDE or installation of the dependent Python modules. I expect that you already have those installed. I'm just going to jump right into the code and walk through the code. The hard prerequisites that you're going to need to complete the tutorial are the Python Jenkins Python module, matplotlib, NumPy, and a Jenkins server with data that you can analyze. Now before we get started, let's do a high-level overview of the modules that we're going to be using in the tutorial. Python Jenkins is a Python module designed to interact with the Jenkins API. So it gives you a really nice interface to interact with the Jenkins API and pull the specific data that you need. Matplotlib is a library that you probably already heard of if you've done any Python programming in the past. It's a plotting library for plotting data on a graph. NumPy is the numerical Python library. This is a very, very powerful library, and we're only going to use it in a very small capacity in this video. Okay, let's go ahead and get started. Okay, so this is my Jenkins server, and it's running locally. I have one job on it, and it's called the Python test job. And this job is only running a very small Python script. In that Python script, I'm just writing a print statement or a sleep statement. And it's randomly sleeping between 0 and 10 seconds. And I'm doing that to provide some variance in the duration, the build durations, right? Because I want to plot the build duration over time. I want to be able to see some sort of trend, so I'm creating some fake data by randomly extending the duration of each of these builds. And right now, it's running on a cron schedule, so it's building every minute. So I'm going to go ahead and pull up PyCharm, and let's get started in PyCharm by first importing the necessary dependencies. So the first dependency that we're going to import is the Python Jenkins module, and it goes by Jenkins. Next, I'm going to import matplotlib, pyplot as PLT, and then I'm going to also import the rest of matplotlib. I'm going to import time, and I'm going to import sys and getopt, and then I'm going to import NumPy as MP, and I'm also going to import datetime from datetime. All right, I'm sorry. From datetime, I'm gonna import datetime. There we go. The reason I'm importing sys and getopt is because we're gonna parameterize the program. So when you connect to Jenkins, either through the script or through the web browser, you have to authenticate with the Jenkins server using your username and password. And it is best practice to not hard code username, password, tokens, and secrets inside of a script. So we're going to parameterize this program to accept a username and password. And so that's why we need the sys and getopt packages. And now that we have all of the dependencies, let's go ahead and I'm going to create a main function. So we'll start off by invoking that main function when the program gets called. Okay. So when the program is called, the main function is going to be invoked, and it's going to pass in the command line arguments that we provide to the program, which is sys.argv. So I'm going to define a main function now, and again it's going to take argv as input, and let's set up username and password variables. Okay, because those variables are going to store the username and password that are provided as arguments to the program when at runtime. And now let's process the options and arguments that are accepted for the program. So I'm going to create two new variables, options and args, and I'm going to use the getopt package to process the arguments. And we're going to create three options. We're going to create an H, U, and P option. And the H option is going to be for help. So all it's going to do if the user invokes the program with -H, it's just going to print the usage of the program and how to use the program. And ideally, when they invoke the program, they're going to use the -U and -P options. So the -U option is going to be for the username argument, and the -P option is going to be for the password argument. Okay, and if that throws an exception, we're going to handle that exception gracefully by printing out the usage. Okay, so I'm just going to say the user should pass in -U parameter, use the -U option with the username argument, and the -P option for the password. Okay, and then we'll exit with the status code 2. Now let's iterate through the arguments that are received and the options. If the option is equal to -H, then you know what we're going to do. We're going to print out the usage. I'm just going to go ahead and copy this here. Alrighty. And we'll exit the program. Otherwise, if the option is equal to -U, that means that it's the username that they're about to pass in, so we are going to set the username to the arg associated with the -U option. And otherwise, if the option is equal to -P, then we know that the argument is going to be the password, and so we'll set the password to the argument. Alrighty. So now we have the logic set up for just invoking the program. Let's verify that we can invoke it correctly. So if you're not using an IDE and you're running this from the command line, then you can directly pass in the arguments at the command line. You can pass in -U and -P. But when you're running in an IDE like PyCharm, what I'm going to use is a run configuration. So under run, I'm going to set edit configurations, and I already have the configuration set, but if I were to create a new one, I would just select the plus sign, and then I would select Python here, and I would specify the path where the script is located, and then I would also specify the parameters. So in this case, the parameters that I'm passing in are username and password, so username Moss and then password Moss123. Okay, and that's really all I need from the run configuration. So if I run the program now, nothing will happen, but you can see that when it's invoked, the parameters are passed in. Okay, great. So our next step is to define a class that will facilitate the procurement of the metrics that we want to look at. It will also facilitate the plotting of the data, and it will allow us to connect to the Jenkins server. So I'm going to define a new class up here. I'm going to call it duration metrics. And I'm going to give it some member variables. I'm going to give it the same member variables that I defined in the main function. So password and username. So when we initialize or instantiate an instance of the duration metrics class, we are going to pass in the username and password that we got when the program was invoked. Okay. So I'm going to define a constructor, and in that constructor we will pass in the username and password. And then we'll set the username and password to the member variables. Alrighty. So we have our constructor, and I'm going to go ahead and call in the main function. I'm going to instantiate a new instance of the duration metrics class, and I'm going to call that instance duration metrics just for simplicity. And here we go. I'm passing in the username and password. Okay. Now, in order to connect to Jenkins, right, I need the username and password. I'm going to create a helper function within the duration metrics class to connect to the Jenkins server. And it's going to return an instance. That function is going to return an instance of the Jenkins server, and we'll use that in all of our other functions. So first what I'm going to do is I'm going to define another member variable called server, and I'm going to set it to null for now. And then I'm going to define a new member function, and this function is going to be, we'll call it connect to Jenkins. All right. Now, when we connect to Jenkins, I'm going to set the server member variable to this new instance of this new Jenkins instance. And to do that, we're just calling the Jenkins class and instantiating it first with the URL of our Jenkins server. And in this case, I'm running it locally, so it's just going to be HTTP localhost on port 8080. And then the username is going to be self.username and self.password. Okay. And so that should return to us in a new instance, a new connection to our Jenkins server. Now, to verify that that connection is valid, what I'm going to do is I'm going to create a new variable called user. I'm going to verify that I'm logged in. And to do that, I can just say server.get who am I? And this will return the currently logged in user. So it just should be my user account. I'm also going to get the version of Jenkins. So I'm going to say server.get version. And then let's print that out to the console. So I'm going to say print hello, and let's do some formatting here from Jenkins. And then I'm going to index into the user the return value of the user variable and retrieve the value associated with the full name key. And then I'm also going to set the version as the second formatted string. Okay. All right, so we made this new helper function. Let's go ahead and call it in our main function. So we're going to do connect to Jenkins. Now when we run the program, we should see this printed out to the screen, and it should say, hello, Moss Norman from Jenkins. Okay, and there we go. So hello, Moss Norman from Jenkins 2.235.1. So we've successfully established a connection to the Jenkins server, and we can now begin querying the rest of the build data now that we're connected. So the next thing that I want to do is I want to retrieve the build durations from Jenkins from the Python test freestyle job. Okay. So to do that, I'm going to create another member function, and I'm going to call it get job duration. Alrighty. Now the first thing that I'm going to do in this function is I want to see what jobs are available in the Jenkins server. So I'm going to create a new variable. I'm going to call it Jenkins jobs, and then I'm going to say server.get self.server get all jobs. Okay, so this should return a list of all of the jobs on my Jenkins server, and there should only be one job. Okay, and I'm going to go ahead and print the Jenkins jobs, and let's go ahead and call that function and then run the program just to see what we get. Okay, so when that's printed, we get back a list of dictionaries, and there's only one entry. And that entry is the only job in the Jenkins server. It's called Python test, so the name of it is Python test. And we're going to use that name to refer to the job in the future as well when we call the API. So we've got the job. Now I want to get information about that job specifically. So in order to do that, I'm going to create a new variable. I'm going to call it my job. And again, I'm going to call the server, and I'm going to say get job info. And I'm going to pass in the name of the job. In this case, it's Python test. I'm going to leave the depth as 0. The depth is the depth of the data that you're retrieving. I'm just going to leave it as the default, which is 0. And then it says fetch all builds, which is it's a Boolean. And this just means, do you want to fetch all of the builds from this job, or if you select false, then you'll only get the last 100 builds. In this case, I'm going to set it to true so that I get all of the jobs. And just note that if you do set it to true, if your Jenkins server has thousands of jobs, then this might take this API call might take a little while. Okay, and let's go ahead and print my job, and let's see what data is included in my job. All right, so when we print job info for Python tests, we get a lot more information to print it out to the console. And after it prints out some of the metadata around the job, like the job URL, for instance, it then starts printing out the builds of that job. And it only includes the high-level data. So it includes the URL of the build as well as the build number. But it does list all of the builds, prints out all of the builds in the console. So now we want to get specific builds and get the information from those builds. So we want to get the duration from each build. How long did each build last? So to retrieve the builds from the Python test job, I'm going to say my job builds is equal to my job.get builds. Okay. And now I can iterate through each of the builds, and I'm going to request info about each build. So high level data is included. So I'm going to go ahead and I'm going to say for build in my job builds. I'm going to get the build number. So build number is equal to build.get number. And now using the number along with the name of the job, Python tests, I'm going to retrieve more information about the job. So I'm going to call a new variable build info, and then I'm going to call server again, and I'm going to say get build info. And the get build info function takes as input the name of the job that you want to query, which in this case is Python test, as well as the number of the build. And we just got the build number in the previous variable there, so I'm going to enter it. Now let's go ahead and just print that out to the console. Let's see what's included in build info. And this is going to print it out for every single build as we iterate over it. So there's a lot more information. Once we hit the get build info API, it includes a lot more information about the build. So it'll include a list of like names of artifacts, for instance, description of the build, and then here's the data that we really want, is the duration, right? So it's in milliseconds. So you can see here this is 9.3 milliseconds, 9.3 seconds, 4.3 seconds, 3.3 seconds, and so on. Okay. So it does include a lot more data. Also, the other key piece of data that we want from here is the timestamp. So here we have this timestamps for each of the builds, and it's also in milliseconds, and it's in epoch format. Okay, so we'll end up having to do some reformatting. So we'll convert epoch format to a regular human readable date time. I'm going to go ahead and comment out those print statements to kind of clean up our console a little bit. So now we know what the key, the name of the key is that we want to retrieve from each of the builds, and we have the build info. So let's go ahead and we'll create a couple of member variables in our duration metrics class. The first variable is going to be a list of build durations. And then the second one is going to be build timestamps. Okay, so when we plot this data, we're going to have we're plotting durations over time. So on the x-axis, we're going to plot the date of execution, and then on the y-axis, we're going to plot the durations. You might be wondering, why not just use the trend data that's included in the Jenkins UI? What is that trend data? Well, if we pull up the Jenkins UI here and I select build history, I can select the trend history here, and on the right hand side you can see the graph, and it shows me basically the same thing that we're going to plot, almost the same thing. But you notice here on the x-axis it's plotting build numbers as opposed to dates, and to me this really isn't that useful. If I see a failure or a trend of failures in the builds, I kind of want to know when that occurred, especially if during that time frame the duration of those builds increase like dramatically. I want to see when that happened. So the build number doesn't really provide me with any value. Additionally, this graph is limited to just the builds that you see here. So you have a fixed number of builds that you can view in this particular graph. So if you wanted to see more, that wouldn't be possible. And if we're going to plot the data using the API, then we can plot a much larger date range. So we could plot the last 3 months of build data, or maybe the last day of build data. So let's go back to PyCharm. And so we have our two new member variables here, the durations and timestamps. And now that we have those, we can start iterating over the durations and append them to those lists, the durations and the timestamps. Okay, so now that we have the build info, I'm going to create a new variable here, and we'll call it build timestamp. And we'll index into the build info dictionary and get the value of timestamp key. We'll also create a build duration variable, and again we'll index into the build info dictionary, and we'll get the value of duration. And now let's go ahead and add those to our arrays of the duration metrics class. So build durations.append, and then build duration, followed by build timestamps.append, and the build timestamp. Now I also want to track the average, so what I'm going to do is I'm going to create a new member variable here, and we'll call it total number of builds. And I also am going to add total duration. Okay. So we're going to add the build duration to the total duration. And we'll also increment the total number of builds. Now let's just verify that we have correctly added those the timestamps and the duration for each build. So I'm just going to print out both of those lists, self.build timestamps and self.build durations. And let's run the program. And it looks like we've correctly added the timestamps. We see the timestamps there and the duration of the build. Now, one thing that I'd like to do with the duration is convert it from milliseconds to seconds. We're going to have to do that anyway, so we might as well do it here. So I'm going to go ahead and modify the build duration variable, and we'll just divide that by 1000. And now let's rerun the program. We should see the durations list converted to seconds. Okay, perfect. So our last step here is just going to be to delete the print statements because we don't want to clutter up the console. And we're already calling the getJobDuration function, so that's good. Now we can actually start plotting the job duration metric. Actually, before we do that, let's go ahead and calculate the average. So I'm going to create a small helper function here, and we'll call it calculate average duration. And so the average duration is going to be self dot total duration over self dot total number of builds. And then we will print that out to the console. We'll just format that. Okay, and let's go ahead and see what that looks like. Oh, forgot to actually call the function. So let's go ahead and add that in here in the main function. Calculate average duration, and let's rerun that. Okay, so our average build duration is around 5.3 seconds. To plot the data, let's go ahead and create another helper function. Let's call it plot job duration. Okay. And the first thing that we're going to do is we're going to need to convert our timestamps to human readable dates. So I'm going to just real quickly sidetrack from that function, and let's create a small function to convert the timestamps to human readable dates. I'm going to call it convert timestamps. Now within this function, let's define an array called dates, and we're going to iterate over the timestamps in this object. So for timestamp in self.build timestamps, we're going to create a new date time object from the timestamp. We'll call that datetime obj, datetime, and datetime from timestamp. Okay. And when we add this timestamp, remember it's in milliseconds, and when we convert it over into a datetime object, we're actually going to want to first convert it to seconds. Otherwise, we'll get an error from the datetime class. And then we're going to append that datetime object to the dates array. And then we'll return the dates array. Okay. So now let's go back to our plot job duration function. And we're going to create a new array called dates, and we're going to call convert timestamps. Actually, let me I'm going to go ahead and modify this, and we'll call it datetime object. Now this is kind of an intermediary step or format for the timestamps. So I want to make sure that when they're plotted using matplotlib, that they're human readable dates. And in order to do that, we first have to convert them to datetime objects, and then from datetime objects we're going to use a function provided by matplotlib that allows matplotlib to show them graphically in a human readable way. So I'm going to create a new variable called dates, and then call matplotlib dates date to number, and then pass in the datetime objects, datetime object array. And just for clarity, let's make that plural. Okay, and we can go ahead and start plotting this data. So let's call pyplot. We'll create a new plot, and we're going to use plot date since the x-axis is dates, and we'll pass in the first parameter, which is the x-axis dates, and then the y-axis is going to be the build durations. I'm going to make it a line style, and to pass that in, you just have to provide a single quotes, and then the dash there will make the plot a line graph. Next, let's label the graph. So on the X label, I'm just going to put time of execution, and then on the Y label, we'll put build duration in seconds. And then we'll title it build durations over time. Okay. And then finally we'll show that plot. Okay, let's go ahead and again, we'll call that function in the main function, plot job duration. Okay, and now that we have the plot job duration function, let's try and run the program and see what our plot looks like. Now, this operation might take some time, especially if you have a large number of builds. In my case, I only have like 130 builds on my Jenkins server, but you might have thousands, so it could take quite a while. Okay, so our plot pops up here on the right hand side of the screen in PyCharm, and to be honest, it doesn't look very pretty, right? We have a lot of variation in our graph. You can kind of see a trend right about here where the build durations seem to go up to around 10 seconds and hover between 10 and 12 seconds. But besides that, it's kind of difficult to see any kind of trend here. So what could we do to potentially improve how this graph looks? Also, you can see along the x-axis, the dates are kind of mashed together, and you can't really tell what any particular date is. So let's address that first before we address the variance in the graph. So I'm going to go back to my plot job duration function. I'm going to put plot.gcf.auto format xdate. Okay. And what this will do is it will auto format the dates so that they don't overlap like that. And let's rerun that. Okay, so now you can see the dates are auto formatted, they're not overlapping anymore, and we can actually tell what each date increment is. So that's helpful. So now I want to address the variance in the graph. I want to smooth out the graph so that I can see a trend. Right now I can't really see a trend in the graph. There is a point where the durations do increase, but I can't really see a trend. So one thing that I can do to smooth out the data here and kind of reduce the noise is take the running mean of the build durations. So take a running average over time of the build durations, and that should smooth out the curve. Now there's an operation provided by NumPy that will make this pretty easy to complete. so we don't have to do, get our hands dirty with math. That operation is a convolution. So we can perform a convolution on this graph, and that should smooth out the data. I won't get into the details of convolution and convolving graphs and stuff like that, or convolving data, but if you were in an electrical engineer back in college, you likely have crossed paths with convolution in like signal processing and stuff like that. In this case, we're using convolution to take the running mean. So you can imagine that we're basically just hovering like a magnifying glass over each of the data points. And as we move the magnifying glass, we can only see maybe like 5 build duration data points at a time. And every time we hover the magnifying glass over a new data point, a new set of 5 data points, we take the average of those 5 data points and we replot those new data points, and those new data points should be a lot smoother. So I'm going to create a helper function for plotting or calculating the running mean rather of this data, and let's just call that function running mean. And inside of that, we're going to call NumPy's convolution operation. So I'm going to declare a new NP array because the NumPy convolution operation returns a NumPy array, which is an array specific to the NumPy library. And then I'm going to call the convolution operation, and I'm going to pass in my durations. And then the next thing that I'm going to do is I'm going to define what's called a kernel. Okay, so the kernel is going to be a one-dimensional array in this case, and it's going to be an array. Since we're trying to calculate the running mean, this kernel is an array of coefficients that we're going to multiply with the build durations. So we're going to take this one-dimensional array and we're going to slide it kind of like overlapping the build durations, and as we slide it, we're going to multiply the coefficients in the kernel with the durations in build durations, and we're going to continue to do that until the kernel is slid across the entire array and it reaches the end of the build durations array. Okay, so let's define the kernel. In this case, because we're trying to calculate the running average, our coefficients are going to be 1 over n, n being the size of the kernel. So let's define an array of ones using the np1s function. And I'm going to specify the dimensions of that as just 10. So it's just going to be a one-dimensional array of ones. And then I'm going to divide that by n, which is 10 in this case. The size of our kernel is 10. And then I'm going to specify the mode of the convolution. And so the mode that we're going to use is valid. So it's only going to convolve. The kernel is only going to use valid data points. It's not going to overflow. If we didn't use the valid mode, we would end up getting an array that is the size of the build durations plus the length of the kernel minus 1. Since we're using the valid mode, we'll actually get a new NP array that's the size of build durations minus the size of the kernel plus 1. So we should end up getting whatever this length is minus 9. The impact of doing that is that we will have basically fewer data points, and the data points won't align with our dates anymore. So at this point I'm caring less about the specific time of execution for the builds, and I'm more interested in seeing a trend in the data, so I can say, oh, okay, somewhere around this time we started to see build durations increase, So that's what I'm trying to get from this. So at this point I care a little bit less about the exact execution time of build duration, and we're going to have to modify the dates array to match the size of this NP array that we are going to return from the running mean function. Okay. Now we have our function defined. It's pretty simple. In the plot job duration function, we are now going to call the running mean. So it returns an NP array, so I'm going to initialize a new NP array and call the running mean function. And I'm going to replace, in the plot.date, I'm going to replace self.build durations with our new NP array. Now, we should get an error when we run this because the sizes are different. So let's go ahead and run this and see that error. Okay. Oh, it looks like I got a small bug here. There we go. NP convolve is the correct small typo. So let's rerun that and see what we get. Okay, so now we get the error that I was expecting. X and Y must have the same first dimension, but have shapes 128 and 119. So 119 being the NP array, and 128 being the size of the dates array. So like I said, the new NP array is the size of build durations, which was 128, minus the size of the kernel plus 1. Okay, so it was 128 minus 9, which is 119. So we're going to have to modify the dates array so that it matches with the same size. And again, like I said, we're losing some data here. We're losing the exact execution time of the jobs, but we're sacrificing that to see a little bit clearer picture of the trends that are happening in the data. So it's pretty easy to modify the dates array. I'm just going to add a colon here. We're going to do some fancy indexing. Colon -9, so that's going to say take all of the dates except for the last 9. And let's go ahead and plot that. Okay, so now we can see, instead of all of that variance in our previous graph, we can see a lot clearer picture of the trends, right? Over time, we can see it dipping down, the trend going down to like 3 seconds, then going all the way up to 8 seconds, back down, and then right about here, we see the trend go way up, and it kind of hovers around 11 seconds. Okay, so this is a much clearer picture than the previous graph. Previous graph, I can tell that there is an increase over here, but with all of this noise, it's really difficult to pick out a trend. And so the convolution, basically, when you're taking the running mean using the convolution operation, you're going to smooth out that data. Okay, so that's pretty much it. I hope that you enjoyed this tutorial. I hope that you learned maybe a little bit more about Python, but especially I hope you learned more about the Jenkins API and how to interact with it. And if you have any feedback or comments, please leave them below in the comments section. And if you like the video, please consider throwing a like on it. Thank you.